Now, they're the first breeding population of beavers in the English countryside in hundreds of years.
This is either a historic day for English conservation or the start of a grave threat to our fragile river ecosystem.
An airplane flying low over a remote valley, dropping wooden crates packed with live beavers, parachuting these animals into the wild as an experiment no one fully expected to succeed. Nearly every one of those beavers survived, and that their descendants have shaped an entire wilderness for more than 7 decades without human interference. It's one of the most remarkable examples of ecosystem restoration in American history.
All the way down to beaver and many things in between. And when you bring them home, you'll restore your ecology. You'll get you healthy functioning again in your meadows, in your alpine streams.
In an era long before modern environmentalism, a bold solution combined surplus parachutes and beaver instincts to transform a barren landscape into a thriving, climate-resilient wilderness. The wildlife crisis in post-war Idaho. After World War II, Idaho found itself facing a unique and escalating wildlife crisis. As veterans and their families moved into rural valleys near McCall and Payette Lake, expanding human settlements collided directly with growing beaver populations recovering from earlier hunting declines. What had once been a slow resurgence suddenly became a source of conflict. Beavers were flooding roads, cutting down ornamental trees, and blocking irrigation canals essential to farming and ranching. These disturbances sparked a wave of complaints that overwhelmed the Idaho Department of Fish and Game. The traditional solution, to trap and relocate beavers, was quickly proving inadequate, cumbersome, and costly as the calls kept coming. At the heart of the problem was the scale and speed of development. The post-war housing boom not only increased human presence, but also cut into beaver habitat. Beavers, with their instinct to build dams and wetlands, were seen as nuisances in these developing areas. Yet they were also a species vital to the health of wild watersheds, so simply letting them be eliminated was not an option. Idaho's wildlife officers were caught in a bind, needing to protect both the new human settlements and the ecological role of a species that was once nearly wiped out. This tension set the stage for an unexpected and inventive solution. Relocating beavers in the past was always a logistical nightmare. The animals required cool, aquatic environments and could not withstand long, stressful transports. Moving beavers by mule through hot summer forests was especially cruel and deadly. Many died from overheating or stress before ever reaching a new home. The traditional box traps and subsequent transport methods were slow and expensive, often resulting in high mortality rates. Faced with surging beaver populations causing growing damage and an increasingly unworkable relocation method, Idaho needed a radical approach that no one had tried before. What made this situation even more urgent was the recognition that beavers were not just any species. They were ecosystem engineers with outsized influence on landscapes and water systems. Losing them on a large scale meant losing the natural processes they supported. The state's wildlife managers understood that removing beavers indiscriminately risked serious ecological consequences. Yet, accommodating both protected wildlife and expanding human interests felt like an impossible balancing act. This mounting crisis was the backdrop for an act of bold innovation that would redefine beaver relocation and conservation itself. Amidst this conflict and complexity, one state biologist saw an opportunity not by looking for new animals to move, but by rethinking how to move the ones they already had. With usual methods proving costly and fatal for many animals, could there be a way to bypass the land entirely? The answer came from an unexpected resource left over from the war, a surplus stockpile of parachutes. What followed was a plan so daring, it sounded almost like a joke at first: to parachute beavers into remote wilderness from the sky. Before that plan took shape, it's important to understand why such an extreme idea was even necessary. Hundreds of beavers had already perished or been lost during relocations, and Idaho's department faced increasing pressure to find a humane, scalable, and cost-effective solution. The stakes were high, and the clock was ticking. Yet, as strange as it sounds, this crisis also revealed an opportunity to study and restore entire landscapes through a species known for reshaping rivers and valleys. The story from here branches deeper into the world of the beaver, an animal whose natural talents for engineering waterways and building wetlands make it an irreplaceable part of the ecosystem. Their return to Idaho's wild spaces would prove to be more than just a way to reduce human-animal conflicts. It would set in motion one of the most significant and overlooked restoration experiments of the 20th century. But before that, the unique nature of the beaver itself deserves a closer look. Transitioning from crisis to the character of the beaver itself, we uncover why this species is often called nature's most skilled ecosystem engineer. The North American beaver's unique role. The North American beaver, Castor canadensis, is far more than a simple woodland creature. It is an ecosystem engineer whose impact rivals that of nearly any other animal on the continent. Adult beavers weigh between 35 and 70 pounds, roughly the size of a medium dog, and sport distinctive orange teeth that continuously grow throughout their lives. These teeth allow them to fell hardwood trees more than a foot in diameter, trees they use to build dams, lodges, and protect their territories. Their thick, waterproof fur, once the backbone of the fur trade, keeps them dry and warm in cold water environments. Beavers live in tight-knit family groups, typically consisting of a breeding pair and their current year's kits, along with one or two older offspring that help raise the young. They mate for life, forming strong bonds that keep the family unit intact. What they lack in sharp eyesight, they make up for with extraordinary senses of smell and hearing, critical for detecting running water, which actually triggers their instinct to build dams. This sensory adaptation ensures they can locate the exact spots where their engineering will have the greatest impact. Beavers inhabit rivers and streams, yet they create their own aquatic environments through their natural behavior. They construct dams which increase water levels to flood adjacent areas, while they create ponds and alter the entire watershed. The wetlands which result from these activities provide habitat for numerous species, which include fish and amphibians, as well as waterfowl and elk and moose, and various migratory birds that depend on beaver-produced environments for their survival. A beaver colony can cut down thousands of trees throughout its existence, which leads to major environmental changes in its area. Beaver wetlands function as natural sponges because they store extensive water quantities during rainy periods and release it gradually throughout times of drought. The system establishes protection against erosion while sustaining groundwater levels and ensuring constant water flow through streams during all seasons. Beavers created diverse biological habitats through their dam construction, which formed multiple ponds and stream networks that European settlers encountered upon their arrival. The disappearance of beavers from the environment caused the complete destruction of its water management system and its natural ecosystems. The beaver population suffered severe decline during the fur trade because trappers constantly hunted them for their fur, which led to disastrous ecological effects. The North American beaver population reached only 100,000 animals by 1900, because European colonization had reduced their numbers from millions to hundreds of millions. The disappearance of beaver dams caused wetlands to transform into dried-out areas which lost their natural beauty and environmental value. Rivers transformed into narrow streams which moved quickly while they washed away their banks and dried up their floodplain areas. The hydrological destruction made it harder for people to control water supplies throughout the western United States. Transitioning from the beaver's evolutionary and ecological importance, the next hurdle lay in addressing the practical difficulties of moving these sensitive, semi-aquatic mammals across rugged terrain. The challenge of traditional beaver relocation. For decades, relocating beavers involved a laborious and often deadly process. Wildlife officers captured beavers in box traps near conflict areas and then transported them to remote release sites using a combination of trucks, horses, and mules. Once trapped, animals would be loaded on trucks to a staging area, then carried by pack animals deep into backcountry habitats. This conventional approach was time-consuming and physically stressful for the animals. Beavers have developed special characteristics which help them survive in cold water environments. The extended hot journeys, which required pack animals to carry heavy loads, caused their bodies to reach dangerous temperatures, while their bodies experienced extreme stress, which made them unable to eat for extended periods. The animals died during the transportation process. The animals who survived the journey to their destination experienced disorientation together with health problems, which made their chances of survival after release into the wild extremely low. The Idaho Department of Fish and Game described this as arduous, prolonged, and expensive. The relocated beavers died because they never had an opportunity to restore their natural habitats. The logistical challenges created a major obstacle, which restricted both the quantity and the pace of relocation operations, even though demand for relocations had increased. Settlers submitted complaints because the process of relocating beavers required extensive time and financial resources to establish a distance which would prevent the beavers from returning. Problem beavers seemed endless, but resources and humane relocation options were scarce. The beaver habitat situation reached a critical point because human settlements continued to expand into beaver territory. The terrain presented an additional challenge which made the task more difficult. The release sites, usually remote mountain valleys and wilderness basins, were often inaccessible by roads. The only method available for transporting goods used pack animals because they had to travel through dangerous conditions for several hours. Semi-aquatic mammals, which normally stay close to water, should not use this transport method, which proves to be unsuitable. Transitioning out of these hardships, the bold innovation that followed took advantage of conditions most would overlook: surplus parachutes and airplanes left over from World War II. Innovation born from surplus parachutes. Faced with the impossible challenge of relocating beavers by traditional means, Elmo W. Heater, a regional conservation officer for the Idaho Department of Fish and Game, saw an opportunity where others saw only obstacles. The Chamberlain Basin, a remote valley in central Idaho, was the perfect habitat for relocated beavers, but was accessible only by small aircraft rather than roads. At the same time, the United States had a surplus of parachutes left over from World War II, equipment sitting unused and available at low cost. Heater's bold idea was to combine these two factors to solve the transportation problem in an entirely new way. His proposal was simple but revolutionary. Capture live beavers near populated areas, load them into specially designed wooden crates equipped with parachutes, fly to the remote basin, and then push the crates out of the airplane. Upon landing, the crates would open automatically, allowing the beavers to walk free and begin their natural behaviors without needing human assistance. This plan sidestepped the long, grueling overland transport that had caused so much mortality and stress. In Heater's own words, it was about getting the right tool for the job and leveraging the materials at hand. Designing the crates was the critical challenge. The crates had to protect the animals during freefall, open reliably on impact, and allow the beavers to exit easily without human intervention. Heater tested numerous prototype models. One early idea involved a willow twig basket that the beavers could chew their way out of, but the animals simply became confused and inactive instead. Another design tried a timer release mechanism, which added complexity, weight, and cost without improving reliability. Each failure taught Heater more about the subtle balance between protection and release. After weeks of trial and error, Heater crafted a solution built from two lidless wooden boxes hinged like a suitcase, with breathing holes drilled for ventilation. Each crate carried 2 beavers, usually 1 male and 3 females split across 2 crates, since younger beavers in small family groups showed higher survival rates than older solitary ones. The crates measured 30 inches long by 12 inches wide by 8 inches high. Parachutes were fastened at the top, while heavy 2-inch elastic bands wrapped from the bottom up the sides, acting like springs. Ropes held the crates shut during flight. The system automated package processing through its intelligent opening system. The crate's contact with ground surface generated force, which destroyed its rope bindings to produce immediate separation of crate contents through elastic bands. The design allowed for box opening without human operation because the boxes were situated in areas which people could not access. Heater understood that humans needed to reach the landing area, but this requirement created dangerous conditions for beavers. His system provided a non-human approach to animal control, which used their natural instincts to operate. Heater needed to demonstrate the system functioned effectively before he could use its complete operational capacities. He needed to access a beaver, which he used for testing purposes. The beaver Geronimo received his theatrical name because he existed as an older male who showed peaceful behavior. Researchers conducted experiments by dropping the prototype crate, which contained him, from heights between 500 feet and multiple test points. Geronimo managed to survive all drops because he exited unhurt from the crate, which opened correctly each time. Geronimo developed a set pattern, which he followed after completing multiple parachute drops until he began to return to his crate for subsequent flights. The study needed people who could stay calm and handle new conditions because their behavior proved essential to testing. Geronimo testing demonstrated crate design innovation, which created fresh possibilities for wildlife management operations. Heater developed his solution by combining three fields which nobody had predicted would work together. Landing crates from the sky was one thing, but what happened once those beavers touched down was even more remarkable. The 1948 Parachute Operation. On August 14, 1948, a twin-engine Beechcraft took off from McCall, Idaho, carrying 8 wooden crates each packed with live beavers. Climbing roughly 700 feet over the Chamberlain Basin, a remote, roadless valley in central Idaho, the pilot and conservation officer prepared to execute one of the most unusual wildlife relocations in history. One by one, the crates were pushed out of the aircraft door, each equipped with parachutes designed to slow their descent and open on impact. The drop altitude between 500 and 800 feet was carefully chosen, high enough for the parachutes to deploy fully, yet low enough to minimize the time the animals spent falling and reduce stress. Conservation officers had spent weeks selecting meadow sites based on water availability, vegetation cover, and distance from existing beaver colonies. Their goal was to maximize survival and ensure the beavers would have ideal conditions to start building dams. Against all odds, 75 of the 76 beavers landed safely and walked free from their crates. The only casualty was a single beaver that forced its way out midair, fell without a parachute, and sadly died. Every other beaver survived the descent physically unharmed and in good enough condition to immediately begin what beavers do best: building dams, creating ponds, and reshaping their environment. This survival rate was extraordinary, especially compared to the high mortality associated with traditional relocation. Heater's detailed accounting showed the entire operation cost between $8 and $16 per beaver, including fuel, parachutes, crate construction, and personnel time, a dramatic reduction compared to the expensive mule transports. Adjusted for inflation, that translates to roughly $190 to $380 in 2025 money per animal. The new method was not only cheaper, but far more humane and efficient, saving time and lives. But the most remarkable surprise was not merely their survival. It was what the beavers did next. Follow-up surveys in 1949 revealed that the animals had begun reconstructing dams within months. They hadn't wandered away or fallen victim to predators in unusual numbers. Instead, ponds were forming and lodges were under construction. Proof the beavers had quickly adapted to their unfamiliar surroundings and resumed their natural behaviors without hesitation. This was possible because dam building is an instinct largely triggered by environmental cues such as running water, the presence of woody vegetation, and stream topography. The beavers did not need to learn how to build dams. They carried the full behavioral blueprint with them. This innate skill meant the parachuted beavers were able to establish territories and start ecosystem restoration immediately. The operation was celebrated as a success in contemporary publications like Popular Mechanics, which dubbed the released animals para-beavers. The Idaho Department of Fish and Game filmed the drops in black and white, though the footage was lost for decades before being rediscovered in 2015. Despite the unusual release method, the story of the parachuted beavers remained relatively unknown until recent years. The complex questions raised by that first flight soon became clear as the beavers began to remold the landscape they had parachuted into. Immediate impact on the Chamberlain Basin. Once the beavers landed safely in the remote Chamberlain Basin, their true work began. Contrary to what many might expect, these animals, dropped from the sky into an unfamiliar landscape, did not scatter or struggle to survive. Instead, within just a few months, they had settled into their new environment and resumed their natural behaviors with remarkable efficiency. Surveyors returning in 1949 found active dam construction well underway, ponds forming along the small streams, and protective lodges emerging. It was as if the beavers had simply moved house rather than taken an extraordinary aerial journey. The instinct to build dams is deeply embedded in beaver biology. Environmental cues, such as the sound of running water, the presence of woody vegetation, and the shape of stream channels trigger their engineering behaviors. Because these instincts are so robust, the beavers didn't require any training or guidance to start reshaping the valley. This innate knowledge ensured they could identify choke points in the streams, fell saplings, and construct dams where others before them might have as well. Their swift adaptation was critical to the success of the operation. The beavers' dam building transformed the hydrology of the basin almost immediately. Dams raised water levels and slowed stream flows, creating wetland habitats that had been absent in this part of Idaho. These wetlands began to act as natural water reservoirs, storing moisture during wet periods and releasing it during dry spells. What had once been a relatively dead or degraded environment slowly began to show signs of renewal, demonstrating how vital beavers are to ecological health and water management. Observations over the following years confirmed the continued expansion of beaver activity. Rather than remaining isolated, the colonies grew and spread, progressively engineering more of the landscape. This quiet rewilding happened without direct human intervention, allowing natural processes to unfold on their own timeline. The beavers rebuilt a world that had been eroded by previous threats, moving the valley back toward a healthier ecological state. The successful outcome at Chamberlain Basin demonstrated how conservation officers selected the site through their careful site selection process. The beavers could reproduce successfully because they selected meadows which supplied needed water and had enough plants. The planning process demonstrated that scientists understood how animals behave and how ecosystems function, which enables them to create current conservation methods. Wildlife restoration's success requires more than counting wildlife populations because it needs animals and their natural environments to achieve a balanced relationship. The operation became distinctive through its implementation of parachute drops and its provision of operational presence throughout the entire mission. The Chamberlain Basin site maintained its natural state, which allowed beaver relocation operations to proceed without any human disturbances or building activities. The researchers created a unique experimental setting which enabled beaver populations to grow without any restrictions on their ability to create changes in their natural surroundings. In North America, beavers could only use certain sites to create water systems and forested areas and wetland environments during extended periods. Initial evidence of success attracted attention, but did not produce any substantial public recognition. The story about parachuting beavers became a strange phenomenon which appeared in black and white video and magazines such as Popular Mechanics. The public did not understand the actual achievements of the animals because their work developed undetected from scientific research and public understanding at that time. The silent change created the base for something much bigger. From the quiet work of those pioneering beavers, a far larger ecological transformation took shape, a process that would span generations and reshape an entire wilderness. 7 decades of silent ecosystem engineering. Over the next 77 years, the beaver population in Chamberlain Basin expanded steadily, untouched by human interference. In 1980, the valley, along with 2.3 million surrounding acres, was designated the Frank Church River of No Return Wilderness, one of the largest and most strictly protected wilderness areas in the contiguous United States. This formal protection meant no roads, motorized vehicles, logging, mining, or development could disrupt the landscape. The only human access was by foot, horseback, or river raft, providing an unparalleled refuge for the beavers and their ecological work. The absence of human disturbance allowed the beavers to continue their natural engineering unabated. They felled trees, constructed new dams, and created an expanding network of wetlands and ponds that altered the valley's hydrology at a landscape scale. This process was cumulative and self-reinforcing. Each dam trapped sediment and raised stream beds, spreading water across floodplains and raising groundwater tables. Increasing moisture encouraged growth of willows, alders, and aspens, precisely the vegetation the beavers relied on for food and building material. The scale of this landscape transformation is rare in modern times. Unlike other beaver restoration projects that experience frequent management or disturbance, the Frank Church Wilderness operates as a living laboratory for landscape-scale beaver ecology. Scientists studying the basin view it as one of the few places where the full ecological power of beavers can be observed without human interference. The results confirm decades of research showing beaver wetlands increase water storage, improve biodiversity, reduce erosion, and build climate resilience. Researchers using NASA Earth Observatory imagery and aerial surveys have documented extensive wetland expansion across the Chamberlain Basin in recent decades. These wetlands provide critical habitat for dozens of species, from amphibians to migratory birds, as well as fish, including salmon and trout. Salmonid populations benefit particularly from the deeper, cooler pools behind beaver dams during summer low-flow conditions, which improve survival rates for juvenile fish. This connection links the basin's health to broader regional ecosystems across the Columbia River Basin. The ecological benefits extend beyond water and wildlife. Beaver-created wetlands serve as natural fire breaks in an era of increasingly frequent and intense wildfires across the American West. These saturated areas resist burning, creating refuges where plants and animals can survive fire events. As climate change exacerbates drought and wildfire severity, beavers play an increasingly vital role in maintaining resilient landscapes. The long-term protection of this area was not designed with the beavers in mind, but it became their greatest ally. Senator Frank Church and others fought to preserve Idaho's backcountry, unknowingly safeguarding an ecological experiment that would unfold for generations. The beavers, once parachuted in as a quick fix to a nuisance problem, became engineers of a near-pristine watershed functioning close to its pre-colonial state. Despite its significance, this restoration was largely unplanned and unmonitored continuously. Unlike deliberate studies tracking every generation of released animals, the Chamberlain Basin experiment is reconstructed through field surveys, satellite data, and scientific inference. Nonetheless, the ecological trend is unmistakable. When beavers are left alone with space and time, they transform landscapes in profound and enduring ways. As the landscape evolved, modern science began to catch up, offering new insights into the climate resilience that beaver-engineered habitats provide. Modern scientific insights and climate resilience. In recent years, science has begun to reveal just how crucial the legacy of those parachuted beavers is for modern conservation and climate resilience. Research from institutions like Stanford University and reviews in journals like Wire's Water emphasize beaver-engineered wetlands as some of the most resilient freshwater ecosystems in North America. These wetlands store enormous amounts of water during wet seasons and release it slowly during droughts, buffering streams against extreme fluctuations that climate change increasingly brings. In a region plagued by droughts and erratic river flows, this natural water regulation is invaluable. Beaver ponds act as natural fire breaks, an increasingly vital function as wildfires grow larger and more frequent across the American West. Saturated soils and dense riparian vegetation created by beaver activity resist burning, protecting ecosystems and wildlife refuges. Satellite imagery and field investigations from recent megafires have documented patches of surviving green wetlands associated with beaver dams, pockets where fires slowed or stopped altogether. In dry, fire-prone forests, these beaver-engineered landscapes literally hold life. Cold water refuges created by beaver ponds also play a critical role in sustaining fish populations, especially salmon and trout, that struggle under warming temperatures. The deeper, cooler pools behind dams serve as sanctuaries during heat waves, offering juvenile fish places to feed and find shelter. These habitats support complex food webs, nourishing amphibians, birds, and mammals, and contribute to the broader health of river systems, including the Columbia River Basin downstream. The cumulative impact of decades of beaver activity at Chamberlain Basin is a near-reference ecosystem, a landscape functioning close to its natural state before European settlement altered it so dramatically. This rarity offers scientists a living example of how a large-scale, undisturbed beaver population shapes watershed hydrology, vegetation, and wildlife over time. It provides insights into the long-term potential of beaver restoration as a natural tool for reversing environmental degradation. The unintentional ecological experiment demonstrates that beavers generate substantial economic value for environmental restoration. Beavers create wetlands which enhance water quality and prevent erosion while boosting biodiversity, and their ecological benefits result in ecosystem service value, which reaches $2 billion throughout North America. The early estimates that valued a single beaver's hydrological work at about $300 over a lifetime hold true, and today those services are more important than ever as climate impacts intensify. The Frank Church River of No Return Wilderness demonstrates how legal protection functions as an effective tool for achieving conservation goals. The land use regulations, which establish complete restrictions against road construction and motorized vehicle operation and development activities, have protected beaver populations and their natural territories for more than 70 years. The combination of ecological engineering with human stewardship creates an effective model for conservation projects, which will take place in the future. The research results are starting to shape policy decisions and restoration work which takes place throughout the American West. Land managers and scientists view beavers as vital partners for developing climate-resilient strategies instead of treating them as bothersome animals, which scientists study. The research demonstrates how beaver wetlands function as flood control systems which preserve natural habitats and protect water resources during climate change. From parachuting beavers to thriving wilderness, this story reveals how innovation and nature's resilience can reshape entire landscapes. If you enjoyed this journey into one of America's most remarkable restoration experiments, be sure to like and subscribe for more stories that dive deep into the natural world. Your support helps uncover history and science that inspire a better future.